Earlier, I had made a video as a supplement to practice problem number 2 from lesson 7 of unit 1. And so I just inserted that video here as part 2.
This is an extension or supplement of practice problem number 2 from lesson 7, no bending or stretching, and unit 1, rigid transformations and congruence. In practice problem number 2, you were asked to describe the rigid transformation that takes triangle A to triangle B. That relatively simple translation of A to B, so you start out at A, move A up 2 units, and A to the right 3 units. That simple translation is the beginnings to understanding how slanted this line is right here, this hypotenuse of this right triangle. What is the angle of that hypotenuse compared to the horizontal side? That is the beginning of understanding the slope of this line. So it turns out that it's actually the reverse of this translation. So the translation of B back to A, that is the calculation of the slope. The key to calculating the slantedness of this line on which this hypotenuse lies is to calculate the length of this vertical side of the right triangle and to calculate the length of this horizontal side of that same right triangle. So to calculate the lengths of these sides, you find the difference. It's the difference of how long this side is right here. This is 3 units long. How long is that side beginning at 0 compared to this length that also begins at 0, from 0 to 3, which is this x-coordinate right here, and 0 to 6, which is this x-coordinate right here. Well, to figure out that length, what you do is you find the difference. You subtract them. You take this length away. So if I slide this triangle over, I'm going to remove these 3 units, and that's going to tell me that this 6 units minus this 3 units is equal to 3 units, which is the length from this point here to this point here. So if I slide it over, this length right now is 3 units, and it is the difference of 6 and 3. So 6 minus 3 is equal to 3 units. Likewise, to find the length of the vertical side, I'm going to slide this triangle down. And so it starts at 4 units, that's this y-coordinate right here, and it ends up at 2 units. You're going to get rid of these 2 units. You're going to subtract them away. So 4 minus 2 is going to slide this triangle down, and you're going to end up with this vertex right here at the origin. So it slides down. This vertex is now at the origin. That's the whole key to calculating the slope of this line. Because now you can just read off the coordinates, and it tells you that the length along the horizontal side is 3 units because it starts at 0 and it goes to 3. So the coordinates of this point is that 3 units right here, and the length along the vertical side are these 2 units, and that's the 2 units right there. So if you take any right triangle and you move that right triangle to the origin, then the coordinates of this point right here is going to tell you the lengths of those 2 sides. Once you know these lengths, then you can use these lengths. So the length along the vertical side, in this case, is 2 units, and the length along the horizontal side, in this case, is 3 units. You can use those lengths to write the slope. The slope is the relationship of how long the vertical side is compared to the horizontal side, which tells you how slanted this line is. So in this case, for example, this length along the vertical axis is 2 units, and that is what fraction or how many times the length along the horizontal side. Well, that is 2/3. This is 2 units out of 3 units along the horizontal side. So that length is 2/3 of 3. And then you can use that to calculate what the length is of y anywhere along this line. So the length of y is always 2/3 the length of x. So this is 2 units, x is 3 units, so 2 is 2/3 of 3. So if I use the value of 3 here, so if x is 3, then what is 2/3 of 3? Well, 2/3 of 3 is, these 3's cancel, you're left with the 2. 2/3 of 3 is the 2 units. And you can actually see it here. This is 1 unit, 2 units. This is 1 unit, 2 units out of the 3. So y is equal to 2. Now, if we move along this line, any point along this line is going to have that same relationship. The length along the vertical side is going to be always 2/3 of the length along the horizontal side. So let's move out to this point that is at x equals 6 and y equals 4. So if x is 6 units, how long is the vertical side, which is shown to you as 4 units? How do you calculate that? Well, this 4 is 2/3 of 6. So 2/3 of these 6 units from here all the way to here, 2/3 of those 6 units are these 4 units from this point here all the way up here. So it's 2/3 of 6 is equal to 2 times 3 thirds, or divided by 3. So I'm going to rewrite this 6 as 2 times 3. These 3's cancel out, and you're left with y is equal to 4 units. This will take some practice, and I'm going to show you how you can practice that right now. Now, this relationship only is true where you read the lengths off of the coordinates when this line goes through the origin. There'll be lots of times when that line does not go through the origin, and there are ways for us to deal with that, and we'll get to that a bit later. To practice comparing the lengths of a right triangle along the vertical side to the length along the horizontal side, I would just pick a point randomly on this grid. I'm just going to pick a point and then calculate what the length is along the vertical side, calculate the length along the horizontal side, and make that comparison. Now, there's not much of a calculation. It's just reading the coordinates of the point, because this line goes through the origin. So this length along the horizontal side is going to be 6 units. This length along the vertical side is going to be 4 units. Turns out that I just randomly picked the point we've been working with. And so this length, 4 units, is 4/6 of this length here. This is 6 units long. This is length is 4 units long. So this is 1/6, 2/6, 3/6. This length right here is 4/6. So the vertical side is 4/6 of these 6/6, or this length along the horizontal side. So wherever you choose along this line, this length along the vertical side is going to be 4/6 of the length along the horizontal side, or the x value. So y is equal to 4/6 of 6. These 6's cancel out. 4/6 of 6. Now think about that. You have $6. What's 4/6 of those $6? It is $4. So y is equal to 4, and this point is that x is 6, y is 4. Now, it has the same relationship. It's an equivalent fraction. It's just a simplified version. It's writing that same relationship with simpler numbers is 2/3. And it goes through this intersection right here. So this is this length along the y-axis, or the vertical length, is 2/3 of this length along the horizontal axis, or the horizontal length. So 2 is 2/3 of 3. This is 1/3, 2/3, that's that 2 units. 3/3, that is the same as 4/6. 4/6 simplifies to 2/3. So using 2/3 as the relationship, you should get the same answer. Y is equal to 2/3 of x. Whatever x is, y is going to be 2/3 of that length. So y is equal to 2/3 of 6. So 4 is 2/3 of this length. So y is equal to 2 times 6/3. So 6/3 is the same as 2. So y is equal to 2 times 2 is equal to 4. And you can see that 2 units is 1/3. Another 2 units would be 2/3. And another 2 units would be 3/3, or 6 units. 1, 2, 3, 4, 5, 6. But this length is only 2/3 of that 6. Right here.